Bismillahirrahmanirrahim. Welcome to second year physics week 19 lecture. Today in this lesson we will discuss about the unit 19 of second year book, that is atomic spectra, and the topics which will be discussed during this lecture will be introduction, production, properties and applications of X-ray. First of all, introduction to X-rays. X-rays, as you all know, that these are the type of electromagnetic radiations which were discovered by Roentgen, William Roentgen in 1895. These are the electromagnetic radiations whose wavelength is very small as compared to the visible light, that is of order of 10 raised to the power minus 10 meter or 1 angstrom, and most of the X-ray have the wavelength ranging from 10 picometer to 10 nanometer. In X-rays, wavelengths are normally shorter than those of the ultraviolet radiations and typically longer than those of the gamma radiation. Production of X-rays. There are two mainly phenomena by which the X-rays are being produced. First one is the inertial transition and second one is the Bremsstrahlung phenomena. First one, the inertial transition. As you know that the electrons are revolving around the nucleus in different orbits, and according to Bohr's theory, whenever an electron jumps from higher energy level to lower energy level, it emits the energy in the form of light. But in case of smaller atom like hydrogen, whenever an electron jumps from higher energy to lower energy, then it emits the low energy light that lies in visible region, as you have discussed or studied in chemistry, that is Balmer series, Paschen series. These are the different series which are observed during the transition of electron in case of hydrogen atom. But in case of higher atoms or heavier atoms, the uh, electrons are distributed in different orbits K, L, M, and N shells, and the electrons which are closer to the nucleus, they are most tightly bound, and whenever they are being removed, then the high energy is required. So in case of an heavier atom, if any of the inner shell electron is being removed, for example, this is the high energy electron which is accelerated by some external source and is allowed to fall on the target element or atom. It strikes with this electron and knock out this electron from the atom, and it also escape from the atom. So a vacancy of electron is produced in the inner shell. Then this inner shell electron vacancy can be filled by either of any of the higher electrons. For example, if this incident electron, which is coming from outside of the atom, it strikes with the K shell electron and knock out this electron, and also it is being escaped, then a vacancy is produced in K shell. Then there is a possibility that L shell electron jumps into this vacancy, and when it jumps from L shell to K shell, it will emit the energy in the form of X-ray. So this is the phenomena which is known as inner shell transition. And in this phenomena, the X-rays produced are called characteristic X-rays. Whereas the second phenomena, that is known as Bremsstrahlung phenomena, this is the phenomena, or this can be considered as the classical phenomena. As you know that whenever a body deaccelerates, for example, when you apply brakes to a car, then it deaccelerates. So it means that its kinetic energy is released from the car, or it is being radiated from the car, and this radiated energy appear as the heat energy produced during the frictional process with the ground or brake shoes. So it means that when a car deaccelerates, it radiates the energy in the form of heat energy. Similarly, when a fast-moving electron is allowed to fall on the atom, then there is a possibility that it is strongly deaccelerated by the nucleus. For example, this is a fast-moving electron. When it passes nearby the nucleus, then due to nuclear attraction, it will be slowed down. And due to this slowdown, its kinetic energy will be decreased, and this decrease in kinetic energy is radiated in the form of X-ray. And the X-rays produced during this process are called continuous X-rays. This is because they have a continuous spectrum, or a long range of X-rays or wavelength of X-rays. So these are the two phenomena by which the X-rays are being produced. Now we come to the main topic, that is the production of X-rays. This is the schematic diagram of the X-ray production. It is the whole apparatus is being placed in an evacuated glass tube. This is the filament F, which is being electrically heated with the battery B. When the current flows through this filament, it heats up, and due to thermionic emission, it emits the electron from this cathode. Then these ejected electrons are being accelerated by an anode on the other side through a high potential of order of 50,000 volts. So in front of this anode there is the target material, which is any of the heavy material, and usually these are either tungsten or platinum. So when these fast moving electron falls on the target material, they either produce the Bremsstrahlung phenomena, or they produce the inner shell transition phenomena, due to which the X-rays are being produced. So as overview, a current is passed through the filament and it heats up. This is the filament which is heated. As it is heated up, the increased energy enables electrons to release from the filament through thermionic emission. So the electrons will be emitted from this cathode. Then these electrons are being attracted towards the positively charged anode and hit the target material, that is either platinum or tungsten, with a maximum energy which is being determined by the potential difference, that is of order of 50,000 volts. As the electron bombard the target, they interact via Bremsstrahlung phenomena and characteristic interaction, which results in the conversion of energy into heat energy and X-ray photon. So it means that when these electron falls on the target material, either there will be Bremsstrahlung phenomena or inner shell transition or characteristic interaction, due to which their kinetic energy is converted into X-rays. But here the main point is, the most of its kinetic energy is converted into heat energy, about 99%, and only 1% of their kinetic energy is converted into the X-ray photons. So the X-ray photons are released in the beam with the range of energy X-ray spectrum out of the window of the tube, and form the basis of the X-ray image formation. As 99% of the energy is converted into heat energy, so this anode becomes hot, so this is kept to be cooled. So for this purpose, a water outlet is being used. This phenomena can also be understood with the help of this video.
Production of X-rays. The lab setup shown here was designed by Coolidge, and hence it is called Coolidge tube. It contains a highly evacuated glass bulb containing a cathode, which is a tungsten filament, and anode, which is a target made up of metal of high atomic weight. The pressure inside the bulb is maintained at 10 to the power of -6 millimeters mercury. When the cathode is heated by passing a current through it from a low-tension battery, it emits cathode rays. These rays are nothing but electrons. The filament is surrounded by a molybdenum cylinder, which is kept at a negative potential to the filament. This repels the electrons further, and hence the electrons form a fine pencil beam at the center of the cylinder. This pencil beam is also accelerated by the cylinder towards the target. The target is made up of a copper block in which a piece of tungsten or molybdenum is fixed. High thermal conductivity is used to carry away the heat generated to the cooling setup. Here we use copper, which is a good conductor of heat and can take the heat away from the molybdenum metal towards the water cooling system. The target is also tilted at an angle of 45 degrees, causing the electrons to hit at an angle. This will produce the X-rays almost perpendicular to the electron beam. A very high potential of 20 kV is applied between the source and the target. Due to the high potential difference, the electrons are accelerated towards the anode and it hits the metal. When it hits, the kinetic energy is transferred to produce X-rays. The intensity of the X-rays depends on the number of electrons striking the metal target. So, if we can increase the rate of electrons emitted by the filament by increasing the current flowing through the filament, then we can increase the intensity of the X-rays. Production of X-rays. The lab setup.
Now we discuss about some of the properties of X-rays. These that they are not being refracted as they pass from one medium to another medium. As you know that whenever the light passes from one medium to another medium, or electromagnetic radiation passes from one medium to another medium, they are being refracted. But as their wavelength is very small and their energy is very high, so they are not being refracted as the normal light. And they also cause the shadow of the obstacle placed in their path. They can be diffracted. Diffraction phenomena is the phenomena in which the light is being spreaded out across its corner or sharp edges. They can produce the fluorescence in many substances. Fluorescence phenomena is the phenomena in which the material absorbs the high energy and then re-emits this energy in the form of low energy photons. Then they can also produce effects on the photographic plates. They produces the black spots on the photographic plates. Then they penetrate in the solid substances which are opaque to the ordinary visible light. They can pass through solids through which the ordinary light cannot pass. And then another property is when they pass through some solid, liquid, or gas material, it can ionize the atoms of that material. Then some of the applications of X-rays. First one is the medical applications. The main application of X-rays in medical is we can detect the fracture in bones, as the bones are more opaque to X-rays than over flesh. So when the X-rays are allowed to pass through a human body, the bone casts their shadow on the photographic plate. So the X-rays photograph reveals the fracture or the presence of the foreign bodies. So X-rays can also be used for curing malignant tissues of the body. X-rays therapy has also been used for the treatment of cancer. So these are the three main applications in medical. As in case of bone fracture, when you fall the X-rays on the human body, then it can pass through the over flesh, but it is opaque for the bone. So when these X-rays fall on the photographic plate, the region from which the X-rays can pass, that is the flesh region, that becomes black, and the bones region uh, from which the X-rays cannot pass that remains the white region on the photographic plate so we can find out the fraction. Similarly, it can be used for curing the malignant tissue as they are high energy X-rays. So when they fall on the malignant tissue, they can kill these cancerous cells or the tissues. Then it has some of the industrial applications. In industrial application, as we again know that X-rays can penetrate through materials, so it can be used to find the defects in the metallic structure in the bigger machines, railway tracks, and bridges. X-rays are also used to analyze the composition of alloys such as bronze, artificial steel, and pearls. The structure of rubber and plastic can also be analyzed and confirmed by X-ray studies. Then it has also some scientific applications. In case of scientific application, one of the main application is the X-ray crystallography, which is named as XRD, X-ray diffraction. With the help of this X-ray diffraction technique, we can find out or determine the internal structure of the crystal, the spacing or the planar spacing in the crystals or dispositions of or dislocation of atoms of the crystal can be precisely determined. So these are the some applications of X-rays. Thank you very much.